Hello, today we are going to cover 6.4 factoring and solving polynomial equations. And we're going to start with a factoring review. We know that the first thing that we do for factoring is pull out the GCF. So I look at the 15 and 10 and they share a factor of a 5. X squared x, they share a factor of 5x. So when I pull that out, 15 divided by 5 leaves us with 3. We had 2 x's, we took 1 out, we've got 3x left as our first term, plus 10 divided by 5 is going to be 2, and we took out the only x. If we have the difference of two squares, we've got two terms. Difference means we've got subtraction. We've got two perfect squares. 9 and 16 are both perfect squares. So we take the square root of 9, 9x squared, that gives us 3x as our first pieces. Take the square root of 16, we've got 4. And what gets that middle term to cancel is 1's a plus, 1 is a minus. When you have regular factoring, the key is that fact that your a value with the x squared is a 1, and you've got a trinomial, squared x constant, and you're multiplying to the outside, adding to the middle. So we want two numbers that multiply to 6 and add to 7, and that is going to be 6 and 1. So we've got x plus 6 and x plus 1. Perfect square, it's the same thing that we do with regular factoring. We want to multiply to the outside and add to the middle. The two numbers that multiply to 36 and add to 6 are 6 and 6. So we've got x plus 6, but we rewrite that, since it's exactly the same, as x plus 6 quantity squared. And our last one is Batman. We multiply the first and the last to get negative 24. Pull our first term down to get 2x squared. Pull down the negative 12. Two numbers that multiply to a negative 24 and add to a negative 5 is a negative 8x and a positive 3x. We factor by grouping. So we pull out our 2x, we're left with x minus 4. Pull out a 3, we're left with x minus 4. So the GCFs come together as our first factor of 2x plus 3, and x minus 4 is our second factor. Notice that this is not squared, that's just our second factor. So those are everything that we should know coming into this chapter. We've got new factoring methods. One of our new ones is the sum of cubes. Sum mean addition. We've got two cubes, so we're adding a cubed and b cubed. When you break this apart, it becomes a plus b, parentheses a squared minus ab plus b squared. Alright, so how do we use this formula? A is the term being cubed and b is the term being cubed. So what I first have to figure out is what is a and what is b. Our first piece is pretty easy. Well, what's being cubed here is x. So x is that a value. 64 is not as easy, so you really have to think, and sometimes it's just going to take some practice and we're going to get used to it, but do 2 cubed in your calculator, do 3 cubed, 4 cubed, 5 cubed, until you find out what number cubed gives you 64. And the number cubed that gives us 64 is 4. So our a value is x, our b value is 4, so keep that in mind. A is x, and b is equal to 4. So when we go to fill our formula in, we've got our a cubed plus b cubed. When I break that apart, it's a plus b, so it's x plus 4, a squared, so that's x squared, minus a times b, which is 4x, plus b squared. 4 squared gives us 16. And that is how we would factor the sum of two cubes. Let's try that again. So what's being cubed here? That is x. What number cubed gives us 125? Well, that is 5. Whoops. Cubed, not squared. So when we break this apart, a plus b, so that's x plus 5, our a squared, so that's x squared, minus a times b, which is 5x, plus your b squared, which is 25. Remember, x is your a, 5 is your b. Alright, our last one, we got a little bit more difficulty here. We've got 8x cubed plus 27. Remember, we're trying to find out what is a. So we're trying to find out what quantity cubed is going to give me 8x cubed. We know that that's x, so what number cubed gives me 8? That is 2x. So you've got to break down both of those, the 8 and the x. What cubed is going to give you 8x cubed? What number cubed gives us 27? Well, that is 3. So here our a value is 2x, our b value is 3. And then we do it the exact same way. A plus b, and then a squared. Now you're squaring that whole quantity, so it's 2x times 2x, which gives you 4x squared, minus a times b. 2x times 3 is minus 6x, and then your b squared, which is plus 9. Alright, so that's one new factoring method. Our second new factoring method is the difference of two cubes. The only change is the two original pieces, instead of adding for the sum, we are subtracting the two cubes. And our formula is a little bit different. A minus b, a squared plus ab plus b squared. So you can see how very, very similar our formulas are. Just remember, if it's the sum of two cubes, your pattern, the a's are the same, the b's are the same, a squared, ab, b squared. The only thing that's different is where the plus or minuses lie. So if it's the sum of two cubes, our signs go plus, minus, plus. Plus, minus, plus. Oops, not a, plus. And then if we have the difference of two cubes, it's minus, plus, plus. Okay, so just remember, if you're factoring with the sum of cubes, it's plus, minus, plus. Difference is minus, plus, plus. Alright, so let's get to factoring these. We have the difference of two cubes, so again, we want to find out what is our a and our b. What's being cubed? In our first one, x is being cubed, minus what number cubed gives you 8? Well, that's 2. So here is our a, here is our b. So we've got x minus 2. It's your a squared, so that's x squared, plus ab, so a times b is going to be 2x, plus b squared. 2 squared gives us 4. So just remember, if it's the sum, your first piece is adding. If it's the difference, your first piece is subtracting. Again, what term is being cubed here? That is 3. What term is being cubed there? Oh, that's x cubed, and that's 3 cubed. So it's a minus b, so x minus 3, your a squared, which is x squared, plus a times b, so plus 3x, plus your b squared, which is 9. And our last one, notice it's very similar to the one that we had right above. It's what piece is being cubed, and we explained that in the last one. It's 2x being cubed. For 27, that is 3 being cubed. The only difference is this one we are subtracting. So we have a minus b, so 2x minus 3, a squared, 2x times 2x is 4x squared, plus a times b, which is 6x, plus b squared, which is 9. And again, we see that the only difference in the formula is where the positives and minuses lie. The numbers are going to be exactly the same. Alright, that's our second new type of factoring. Our third type is only semi-new. We've done factoring by grouping as the last step in our Batman. So if we go back up to our review, grouping is these two steps. Grouping the first two together, pulling out the GCFs. So we're going to take that and apply it. We just have kind of a different setup here. So we've got x cubed minus 2x. We group those two together. We group our second two together. When we look at our first two, the GCF that they share x squared. When I pull that out, I've got 3. I take 2 out, I've got 1 left. And then I have minus 2 left there. When I look at my second piece, remember you always want that x to be positive, so I'm going to pull a negative 9 out, and that's going to leave me with x minus 2, because 18 divided by a negative 9 leaves us with a negative 2, so make sure that you're dividing that out correctly. And again, remember, with factoring by grouping, these two pieces must be exactly the same. If they're not exactly the same, then you did something wrong, or you can't factor by grouping. You can't always factor by grouping. We take our two GCFs, x squared minus 9, that becomes our first factor, and then the x minus 2 is our second factor. When we are factoring, we want to make sure that we factor as far as we can go all the way. Now x squared minus 9, hopefully you recognize that and remember that it's the difference of two squares. We've got subtraction, we've got two perfect squares. 1 is a perfect square, so that becomes x plus 3, x minus 3, and x minus 2. And that would be completely factored. Alright, our next one, again, group your first two, group your second two. Our GCF between our first two is 10x squared. We are left with x plus 2 on the inside. Here, there's nothing that they share, it's already positive, so I pull out that positive 1, and we've got x plus 2. Take the two GCFs, 10x plus 1, that becomes our first factor. X plus 2, since they're exactly the same, they become our second factor. Again, if they weren't exactly the same, it would not be factorable by grouping. We look at our first one. Last time we had x squared minus 9, which we could factor further. When I look at these two pieces, there's no GCF, and there's no difference of two squares. If I have two terms, those are my only options right now. Or sum of cubes, difference of two cubes. Neither of those fit, so that's as factored as far as it can go. Alright, flip over to the back page. Almost done. We've got one more factoring method left, and that is quadratic form. So we aren't necessarily factoring a quadratic here, but we're going to follow the quadratic rules. So if I factor x squared plus 6x plus 8, this is a quadratic because we have an exponent of 2, we would multiply to the outside and add to the middle. Well, the numbers that multiply to 8 and add to 6 are 4 and 2. So this would be x plus 4 and x plus 2. Now when we look at our next problem, we see that it's very similar. Our coefficients are the same, except for this is to the fourth and this is to the second. We're still going to follow those same rules. We're going to multiply to the outside and add to the middle. So we've got the 4 and the 2. The only difference is we don't want our middle term to be an x and an x squared. We want it to be to the fourth. So we have x squared plus 4 and x squared plus 2. And remember, you can always check if you factored correctly because you can just FOIL it back out. X squared and x squared is x to the fourth plus 2x squared plus 4x squared plus 8, combine like terms, and we see that we ended up where we started. So we know that we factored correctly. When you are doing this, just make sure that just like this was 2, 1, it has to be 4, 2. So we've got 4, 2, we are multiplying to the outside and adding to the middle. So we have multiplying the outside, adding to the middle would be x squared minus 6 and x squared plus 2. Okay. The next ones are going to be quadratic form of difference of two squares. We have a subtraction sign, we've got two perfect squares. So it's not a quadratic, but it's going to follow those same rules. We break it into two pieces. If it's a difference of two squares, we know one's a plus, one's a minus. The square root of 4x to the fourth would be 2x squared. As our first pieces, the square root of 9 is 3 and 3. Now we double check. We've got 2x squared plus 3, 2x squared minus 3. We can't factor those any further, so we're done. We look at our next one. Again, we've got subtraction. We've got two perfect squares. So we've got the difference of two squares here. The square root of 64x to the fourth is 8x squared. So those are my first terms. One's a plus, one's a minus. The square root of 25 is 5. Again, we make sure that we always look inside and see if we can factor as far as we can. We can't factor that anymore. We can't factor that anymore. And last, this one we may look at and kind of be like, okay, let's try Batman, but don't forget the first step of factoring is always to check for your GCF. So 4, 20, 24, they share a factor of 4, x squared, x to the fourth, x to the sixth, x to the fourth, x squared. I can pull out two x's, so that's x squared. When I pull that out, I'm left with x to the fourth minus 5x squared plus 6. Now that I've done my GCF, I look, and this is following the quadratic form of regular factoring. We multiply to the outside, add to the middle. Just remember that one little change is it's x squared as our first terms instead of x's. Well, the two numbers that multiply to a positive 6 and add to a negative 5 are a negative 3 and a negative 2. Once we've done that, we again check to see what's inside. Can we factor x squared minus 3 any further? No. Can we factor x squared minus 2 together? No, any further? No. So this is going to be our answer. Alright, we are almost done. The last thing we're going to do is put it all together. So what I want you to do is you've got these three problems. I want you to press pause and see if you can apply all of your factoring rules, old and new, to get these factored as far as possible. Don't forget to check for GCF first. Alright, let's see how you did. For the first one, we have to start by pulling our GCF out. When we are left, we have the difference of cubes. Our A value is x, our B value is 4. We have our GCF still at the front, we don't lose that. And then the second half is that factoring by difference of difference of cubes. X minus 4 can't be factored any further. The second piece would be regular factoring, but there are no two numbers that multiply to 16 and add to 4, so that is factored as far as it can go. For our second one, we start by pulling the GCF out of an x first, then we factor by grouping, pulling the GCF out of each piece. So we keep our GCF of an x on the outside, then our GCFs of the grouping become x squared minus 4 and x plus 3. X squared minus 4 is the difference of two squares, so we got to keep going. So that becomes x times x plus 2 times x minus 2 times x plus 3. Our last one, there is no GCF to start with. That is the difference of two squares. 81x to the fourth is a perfect square, and so is 16. So when we square root 81x to the fourth, we get 9x squared as the first term. Square root of 16 is our second term of 4. 1 plus 1 minus. We check the first piece. 9x squared plus 4 can't factor any further, but our second piece of 9x squared minus 4 is the difference of two squares again. So we've got the square root of 9x squared is 3x as our first pieces. Square root of 4 is our 2 for our second pieces. One's a plus, one's a minus. So the key for this section in factoring is just making sure that you've gone through and you've factored as much as possible so that it's completely factored form. Alright, and we are done for today.